All right. So we're doing KSP now. And solubility. So back in the first term of chemistry, you guys should have all learned about net ionic equations, and you studied solubility. But there it was just a yes, no. It was qualitative. So something either was soluble or not, and you may have memorized the precipitation chart, or you were shown a precipitation chart, and I'm going to go through that and show you a shortcut so you don't have to keep looking up charts and stuff. What we're going to do now is we're going to do the math. We're going to quantitatively figure out how soluble something is. And the reason we had to wait until this term to do that is because it is based on these double arrows. So we had to study equilibrium to be able to do it. Now the key to this chapter, titrations is the hump. So we could have done this chapter first, but it's better to get through the titrations, and then we'll get to this, and this should be smooth sailing from here on out. The key is it's always the solid to the ions. So as long as you always do solid to ions, aqueous, makes it really simple. They're always written like this. So the confusing part for many students was back in 221, you learn net ionic equations, and we would mix two things and we would make a solid precipitate. So you got trained, the solid is always on the product side. The solid's always on the product side. We're doing equilibrium now, so we're writing it for KSP's always the solid to the aqueous. So keep that in mind for today and tomorrow, and it makes everything a piece of cake. Also, this gets a constant, and it is called KSP. Can you guys see the red? Maybe?
Yes.
Okay. If you remember, very first lesson this term, we ignore solids. Solids don't affect equilibrium. So KSP equals, in this case, just the ions. So the barium times the sulfate. Now this was a question way back, can't remember if it was on the lab or something, the very first lecture, the very first 2-3 days. You do want to show them as ions. The charges go inside the brackets. This is the key to this chapter. Every single problem I do, every single problem you do, the very first thing you do is write your equation, solid to ions, and write your KSP expression. So notice, we don't have to deal with numerators and denominators. We only have numerators. We ignore the solids, so it's always divided by 1. So it makes this chapter not so bad. All right. Couple things about solubility. Solubility means KSP measures solubility. It's how much dissolves. That is what KSP tells you. The opposite of that would be how much precipitates. KSP does not tell you that because it does not tell you about the solid. It tells you how much went into that. And because of that, I actually gave you the chart so you don't have to look too far for it. KSPs are less than 1. They're actually significantly less than 1 usually. And so when a K value is less than 1, here we go, it's our first bonus point for the day. What does it mean when the K is less than 1?
Reaction is reactant favored.
It is. Thank you, Baker. It favors this direction, like significantly. When you see the numbers that we're going to start using, like 10 to negative 10, 10 to negative 9, 10 to negative 25, these things are pretty much forming the solid. We only have a wee amount, only a little bit of the ions form. And so solubility is, we'll come back and talk about that in a few minutes. It is temperature dependent and pH. The temperature and the pH both affect the solubility. And so this is why, for those of you who did get to do labs in 221, things were often labeled that it was something in HCl or in NH3, and that's because we play with the pH to get things to dissolve, because they form a complex ion. Couple other things. Unless you were told otherwise, you're at 25 degrees Celsius. This is considered standard temperature. Gas laws, again, are different from everything else in chemistry and physics. 25 is considered standard temperature, except with gas laws. And the other thing is, since we're using ions, we're going to only be using molarity. So you do have to be in molarity to plug in for the barium and the sulfate. So we don't have to worry about ATMs. And I have a note. Oh, it says we're going to write some KSP expressions. So I wrote these out as words because it's good for us to practice naming. So calcium phosphate. Hopefully you guys know calcium. Calcium is Ca. And I'm going to write the charge up above. It's a +2. Hopefully you have a periodic table. And I know you guys can always just look at charts and look at charts, but you really should know calcium. And looking, the only chart you should need is your periodic table. Phosphate is PO4, has a -3. Those of you who had me, I gave you that chart. Hopefully you still have the periodic table. I have a whole bunch of them in my office. But phosphate is one of the polyatomics that shows up a lot and keeps showing up in other chemistry classes and other biology classes. And so this would be 3 calciums for every 2 phosphates. You guys remember writing formulas, chemical formulas back in 221? There's like a question on the final, like one question. And so it should be one where you go, oh yeah, I know how to do that. So for this chapter, you start always with the solid. So you start with the compound, and then you break it up into its ions. This subscript goes to the front, becomes the coefficient. So you have 3 calcium ions. Now, this is aqueous. I leave the aqueous off, partly because my arm gets really tired just from writing on the board and stuff. I'm okay. You have to show the charge once you're on this side of the equation. You can leave the aqueous off. You want to show the solid so you remind yourself it's not part of our, it doesn't affect the K value. And 2 phosphates. So if we wrote our KSP for this, calcium with the +2 in the bracket and raised to the 3rd power. And then PO4 to -3 raised to the 2nd power. And I said write notes to myself there to keep track. Questions on that? This is the key to this chapter, is being able to do this first with every single problem. And it goes back to ions. I keep mentioning, we keep going back and reviewing stuff. This class built on the previous 2 terms. And some of you had a stronger foundation, and the others, you're getting it now. So that's our formula. Let's do the second one. So chromium 3, what does that Roman numeral 3 mean?
+3 charge.
Yeah, so that charge, it's telling you, well, when do we see Roman numerals 3? To get the full point, Harrison.
With transitional metals.
Yeah, transition metals can have variable charges, and it's because of the d orbitals. And yeah, hydroxide, I'm pretty sure you all know hydroxide now, that you've become pretty familiar with that. And you do want to put the OH. You know, as a question that comes up in 221, students are like, why do you write hydroxide as OH? I'm like, because everyone does. They're like, but why don't you write it as HO? really doesn't matter, but I'm pretty sure you guys all just write it as OH now because we did so much with it over the past 2 weeks. All right, write your little solid. And again, the +3, that came from the Roman numeral 3. So that is just with transitions. Calcium, 1As and 2As, we never put Roman numerals. All right, so on this side, we get chromium to the +3 and 3 hydroxides. And then you write your KSP. And I can't see myself. All right, questions? And then I have a little note there, and we're going to go through this real quick. We'll see if anybody from my class, well, actually, I've talked about this term a little bit. There are some ions that we will never see in KSP. In that chart in the back of the notes, you're not going to see them. So they're always soluble. Is the brown showing up? Somebody will tell me if it's not. I think I have a black. The ones that are always soluble, so there's no KSP. Anybody know? Can you guys see that part of the board? Maybe.
Is it the 1A metals?
The 1As are, yeah, so like sodium, potassium, lithium. There's more. Do you know another one, Sam? There is one more cation that's always soluble.
Oh, is it the NH4 plus?
It is. And actually, there is one more, and it's part of the 1As, even though it's not part of the 1As. It's what we've been talking about, and that is hydrogen. So acids are soluble. We're not going to see them showing up. So whenever you see these, and this becomes important in a couple pages, today I think I mostly stay with, we're getting used to this formula, but when we see those, if they show up, like if I say, hey, you're gonna, to make the calcium phosphate, you're gonna mix sodium phosphate with something, you ignore the sodium, it's always a spectator. So always soluble means it's always a spectator. And we'll see. I think Aaron's the only one here who's been with me. This is my best friend. I have 3 camels. I don't need any more camels. Went to school yesterday and got them from my office. But this is the best swimming camel of all time. If my students were here, they would know who I'm referring to. So Nick the camel always swims, always a spectator. If you see Nick, you're going to cross these out of the question. Nick doesn't show up here because he doesn't form a solid. He's always a spectator. It was a question on that first lab, Le Chatelet's principle. There are some other ones. I tend to stick with Nick and those. And yeah, let's leave it at that. If you want more of them, there's like four anions that are always soluble. All right, questions. We're going to calculate KSP. So I redid the notes. I put more pictures on for you guys. But all my answers, you guys, I put answers on yours. I'm going to erase. And I just realized my eraser is next door. Let's see if this will erase. Oh, I left it out because it's not that big a deal. But the SP after the K, I'll go find my eraser when I give you a problem to do. Wow. See, the squid hat works really well. Any eraser I ever had. Stands for solubility product. And I guess they called it that because the ions are always the product. This was my quote of the day. We all have to let our inner child out more. And I like my blue pen. Let's just switch to blue. And I'll hold on. Nick's swimming with me in the squid, the rainbow squid. Very sad nobody got dressed up today. Didn't take me seriously. All right, so we're going to calculate KSP. And it tells us we have silver chloride. So what's the first thing you're going to do? Oh, I failed.
Write the equation.
Thank you. You're going to, and what else? To get a full point, Aaron.
Oh, and use the ions, put the ions on.
All right, let's write the equation, see if you remember what the other thing is you want to always do. So silver chloride, silver, by the way, likes to always be a +1. And then chloride is a halogen, so it's a -1. Write your solid. What's the other thing we need to do, Aaron?
Yes.
Yeah, write your KSP. So that is the most important thing with this chapter. I didn't post your homework. I will today. Sorry. You guys have enough to do today, which is that big titration lab, which may be driving you crazy today, but on Friday, when you get to those pages on the test, you'll be like, oh, this is so easy. I've got it down. So you get a gift that no other class has gotten before, because I had to have you do something since you're not in lab. Always start every problem, start with that, with KSPs. And then we're solving for KSP. So we don't do full mice charts here. It tells you a saturated solution. So here we go. Somebody who hasn't answered yet. What does saturated mean? Maybe. Maybe. Maybe not.
Possibly lesser hydrogens. No.
No. This is a good try.
Did you say unsaturated?
No, it's this, if you read my notes, it says saturated. Saturated means we have the maximum in there that will dissolve. You're at the maximum. So our saturated solution means what is dissolved is the 1.34 e to -5. Now it says silver chloride because it breaks into these two. These are both 1.34 e to -5 because there's just one of each. So those would be our KSP then is equal to that. And we punch it in and we get my answer. Pretty simple. All right. Write out your equation for your next one. Set it up. I have to go get water real quick while you guys are setting that up. All right. So, strontium fluoride. Do we know anything about it? Non-magical. Does anybody know strontium is SR? Actually has some really cool niche uses. Not magical. It's usually radioactive because of where it is on the periodic table. Always start with the solid. Why do I have a subscript 2 there?
Because strontium is +2 ion.
Strontium is a 2A. It's a +2. It is, what's the name of the family?
Alkali.
Earth metal.
It is the earth metals. All right. Harrison's like going for it here. So strontium fluoride, this would be a +2 -1. Technically in the compound, we don't show the charges. On the other side, you will show your charges. And I'm okay with you leaving the aqueous off, but you can write aqueous. And of course, you're going to write your KSP. So for this one, I started you with that you have 11 milligrams and 100 milliliters. Back to what I said earlier, you have to be in molarity. So we need to figure out our moles per liter, assuming you guys have the same problem I do. This was a trick I mentioned last week or the week before. If you have milli over milli, you can just cross the 2 millis off. So metric does work that way. Only do that trick, that really cool shortcut, if you get it and you see it. If you're ever unsure, go through the steps, but you would be multiplying by 1,000 and dividing by 1,000. So we have the liters. We just have to change our grams to moles, and we do it for the whole compound. Whenever you're using that periodic table, you're using the whole compound. So 125.6-ish grams to mole, and our grams would cancel. We'll have moles per liter. I have no idea what that number is. This, though, molarity, that is your strontium. Did somebody punch it in? Or can somebody? Do I have a calculator in here? I do. All right. It's hard to believe I never wrote the number down. I think my students always told me the numbers. All right. So I got that this is 8.76 e to the negative 4 molar. Because this is a 1-to-1 mole ratio, this number is your strontium. So my question is, what's my fluoride number?
Is it twice that?
You have to have twice that. So I'm going to show you the step. You don't have to actually show the step, but it can help students. This is technically the strontium fluoride, right? Because that was the mass of the whole thing, which you do need to use because the mass was of the whole thing. For every 1 mole of strontium fluoride, you have 2 moles of fluoride. So it would be double that. So I'm just going to say 2 times that number, 8.76 e to the negative 4. Not only do I double it, I square it, because that's part of the KSP. So you double it to find the molarity. That's what my 2 here is. So I'm doubling it, and I'm squaring it. And that will give you your that will give you my answer. 2.69 e to the negative 9. All right. By the time we get done today, these you'll be like, well, this is so much better than titration. Or maybe you'll miss the mice charts. Questions? I've turned the page. We're gonna move on. All right. So now I'm giving you the KSP. It doesn't really matter. First thing you want to do is say, write your equation. So write your equation, write your KSP. I'll sit here and hum for a moment. I was asking somebody that, and I'm like, do you hum? And they're like, I've never hummed in my life. And I'm like, really? Like, do you sing to yourself when you're like by yourself? Nope, never did it. I'm like, even as a little kid? Nope. I was that kid who sat in the back, never sang along in kindergarten. Kindergarten was apparently traumatic for him. All right, so I'm done humming. So never ever tell me you have no idea. At least start by writing your formula, your equation, solid to ions, and say, okay, I got that much. I can write my KSP. Look at that. Here's a question for you. 2 weeks ago, could you have done that? Probably not. Oh, maybe one or two of you knew what equilibrium was. All right, this time I gave you the KSP, 3.9 e to negative 11. And that came from my all-knowing and the connections to the matrix, but it also came from, at the back of your notes, are two charts. One is going to show up at the end of lecture, but there is 2 pages of KSPs, and they are by the cation, alphabetical. So lead is under lead, not PB. It really confuses me because I alphabetize by the elements, but anyway, and KSP values are given there. KSPs are always just 2 sig figs because they're really approximations because they're really small number because not very much dissolves of any of these. So that's all we know. It doesn't tell us anything else. So this must be X and this is 2X. There's nothing, that's it. That's all we can do. If I have an X amount of calcium, I have 2X of the fluoride. I know my KSP. So I'm going to have X. And then the 2 and the X are both squared, which means this is 4X squared times the X. This is equal to 4X to the 3rd power. We see 4X cubed a lot in the next 2 days, next 3 days. And you get used to it. Like by tomorrow, by the end of this hour, you'll be used to it. And it's whenever you have a 1-to-2 ratio. So an earth metal with a halogen, which the earth metals are called earth metals. In case you didn't know, you probably guessed they're found in the earth, but earth is solid. Anything solid was called earth. So if you go back before we started having to give everything symbols and stuff and overanalyzing everything, earth meant solid. And that's what we're studying right now, are solids. So we're going to see a lot of the earth metals. So we're going to run into 4X3, and they precipitate always with the halogens. They pretty much precipitate with everybody except nitrate. I don't know if anybody else knew Nick the Camel, or is that just my class? All right, you guys can just solve for X. I'm going to take a moment to solve on this one because there's going to be 1 or 2 people wondering. You would, of course, divide by 4. A quick comment, it was a question Erin asked me. All I need for you to do is show me the setup. You can even leave this out. You can just say 4X cubed, because you get used to when you have an X and a 2X, it's 4X cubed. And then you can just tell me, okay, my X is 2.14 e to negative 4. We're not done. You would divide by the 4, and then you would have to take it. I take it on my calculator to the 1/3 power, or you can take it to the cube root. If you're not sure how to do that, please talk to me. It will take us 1 or 2 minutes to figure out on your calculator. What are the units of X?
Molarity?
It is. Rather than writing it as molarity, I recommend you write it as moles per liter, because we're going to solve for grams per liter. And it wants the grams of the calcium fluoride. So we need to use the total mass of calcium and the 2 fluorides. So that's where I got my answer. I don't know if I gave you guys answers on this. We're going to take it one more step. And that is a question or a comment you're going to see show up on the worksheet. And again, somewhere it will say, please report your answer to the appropriate metric prefix. Metric is beautiful. It gets rid of the zeros. So there are a bunch of you in my office hours earlier and doing the titrations, and there were all these zeros, 0.000. we're going to get rid of the 0. So what metric prefix could we use? There's actually 3 I can think of here. Anybody? Pick one.
Centigram?
What?
Centigram?
You could do centigram. Centi would be that we move our place value to. You could also do milligrams. I don't know if I gave an answer. Centigrams would be 1.67 cg, or you could move it 3 places, 16.7 milligrams per liter. Either one would be fine. If you moved it 1, it would be decigrams, so 0.17, 0.167. Hopefully you all feel better about metric than you did a year ago, because that's one of the things in general chemistry. Scientists, medical field, engineers, it's all in metric. You need to embrace metric and see this as the opportunity to do that. All right, the next question. As I was babbling along, hopefully you already did it. That's what they used to do. I want to comment on this one. This is not a typo. This is not nitride. This is not nitrate. This is azide. It is a weird ion. It is actually, I get it right over here. The copper is a +2 and the azide is N3 to the -1. It is an extremely unstable ion. It's a triatomic ion. It is in all your airbags in your car, and nitrogen does not want to be N3. It's put together wrong, and it fills up, it becomes N2 gas as soon as you barely touch it. And N2 gas will take up all the space, and then your head doesn't get hurt by the steering wheel. All right. This would be 2, because there's a 2 here. This is X. This is 2X. You write your KSP. Copper ion. And 3 azide squared. So it's a 4X cubed. You plug in, you solve, you go through all the steps. Blah, blah, blah. I'm not going to walk through all of them. I wanted to mention something and now I lost it. Right. Yes, with sig figs, this is not what I wanted to mention, but KSPs are always approximate. Your answers, technically, you can give your answers always with 3 sig figs. I'm fine with that. Really, like the previous one, we only would know it would be around 17 milligrams. It's a serious hand waving. So you would solve for X, 5.4 e to -4. Again, that's moles per liter. And in this case, then we can go all the way. It is always moles per liter. We would have to multiply by our moles per gram, grams per mole of the whole compound, and also by the 0.5 liters. That was given in the problem, that you have 500 milliliters. And you would solve, I gave my answer as milligrams, so 40 milligrams. So questions. The key again, write your equation, write your KSP expression. On the previous set, we solved for KSP. On this one, we knew the KSP, and we're just solving for X. You don't have to make ice charts. Please do not make ice charts. There's always just this one piece. So write your equation, write your KSP, no ice charts. All right. Questions? I'm gonna erase the previous one. All right. Common ion effect. We've seen this before. All right. We have PbCl2. Saturated again just means you have the maximum amount in there. So this is our equilibrium equation. All right. So we're not doing any math with this one, so I'm not going to write my KSP. We'd have to look it up. My question is, what happens if you add NaCl? This is all Le Chatelier's. You guys remember him? He did a whole lab, like less than 2 weeks ago, like 12 days ago or 10 days ago. I know, it's been so long. All right. If you add NaCl, you increase the chloride. Somebody who has not answered yet, what's going to happen when you add more chloride, according to Le Chatelier? Maybe nobody else is here.
It'll favor the reverse.
It will go in the reverse. And so my question was, to get your full second point, Aaron, how does that affect, or how does that affect the solubility? Is it more or less soluble?
I'm gonna guess less.
It is. So it's shifted toward the solid. So you increase the chloride, it shifts reverse, it's less soluble. You can also say more solid, more precipitate. PPT is precipitate. Yeah, it's, so he answered that beautifully. And just be careful of that. So the forward direction is soluble, the reverse direction is precipitate. All right, so you guys know how to do this. PbNO3. Oh, the sodium we can ignore because it's always a spectator. The lead nitrate. Again, we can ignore Nick. Nick is swimming with the rainbow squid in here. And so we're adding more of the Pb. So it's going to shift reverse because you've increased the Pb. So again, less soluble. This is the common ion effect. You can Google it. I'm sure they give you a really elegant definition. But if you add a common ion, it's going to shift the reaction. And so for KSPs, it always shifts it back towards the solid. Make sure you read the question. In this case, I asked what happens to solubility. They become less soluble. Sometimes I ask the question, do you get more or less precipitate? So you get more precipitate for both of these. And then we get to C, and it's KNO3. Well, you see Nick. Nick is swimming. Nick's a spectator. Oh, and you see potassium. Yeah, the 1A's just get kicked out of everything, don't they? And Nick, they don't affect pH, and they don't affect solubility. So if we cross them both out, no effect, no change. If you were asked to explain why, no common ion. Or you can say they're just spectators. Which takes on a whole new meaning in this coronavirus days, where what, the NBA was like sequestered in Disney World. And so there really were no spectators, other than Mickey Mouse. I'm assuming Mickey's okay. I don't think mice get the coronavirus. Camel. All right, that was pretty easy, right? So now we get to do math. All right, if there's no questions, first thing you guys are going to do on the next problem is write your equation and write your KSP. So go ahead and do that. Well, I found my eraser. Go figure. All right. Silver chloride, we did this one. Fairy dust. Oh, I'm missing all my questions. I love this chapter because it's all the gems. All right, this is just the fairy dust question. Write your KSP. Aaron, you gotta mute yourself.
Oh, sorry.
You're okay. All right. It just says how much dissolves. So we'd look up the KSP, 1.8 e to the negative 10. We did it on the previous page, or when you do your homework, you have that chart in the back of your notes. And these are just x and x. So it's just x squared, right? You solve for x, and once you get x, you can go all the way to grams. I'm not going to walk through all the steps. I'm just going to go that my answer is 1.9 milligrams. All right, now we're going to do B. Still have the same equation. It's up to you if you want to write it out again. You can just, some people do, some people don't. What happens here is we're going to add 0.100 molar sodium chloride. I'm writing it over here just so I know. The sodium doesn't matter. What I've added is the chloride. X, I'm actually going to go back a step. I do want to write my X from the previous step, 1.34 e to negative 5. Again, that's molarity. If you have not noticed, which you probably have not, all the numbers we're working with KSPs are really small. You're not making ice charts here because the change is always so small. So this is my chloride and the silver is X. And you just plug in KSP equals that. So again, this is my silver, is my only unknown. The chloride is just 0.1. In this chapter, and only with KSPs because they're so small, if it gives you one of the ions, you just plug it in. The hardest thing for most students is what we just did, where you just, anytime you see sodiums, you cross them out. Anytime you see potassiums, anytime you see Nick, because they're always spectators. They don't precipitate, and that's what this is looking at. All right, use the same KSP. X is 1.8 e to negative 9 moles per liter. You go all the way to grams of the silver chloride because it's a 1-to-1 mole ratio. And you'll get 26 micrograms. So this funny symbol is micro. And you should have learned this way back in 221, but you feel overwhelmed about everything. That symbol has killed a lot of people by doctors because people's handwriting is abysmal when they're writing prescriptions because they seem to not care. So the symbol has changed when it's put in front of grams, and it is typically now written as MCG. That is only when it's put in front of grams in medical and pharmacy and stuff like that. And so you can write it as MCG or you can write it as the mu sign. Just make sure people can see the difference between milli. This is milli. And that is micro. So milli is 1,000th of a gram and micro is 1,000,000th. It's all about communication. And if you can't communicate, people die, and that's really not cool. All right, 1C didn't make the page, but let's put it on there. Does your answer make sense? Does it make any sense at all? This is right under the common ion question. Well, I added chloride. It's shifted reverse. And so it is less soluble. Less soluble means less dissolved. just in case you didn't guess that. This side is how much precipitates. This side is how much dissolves. KSP is telling you how much dissolves. This is how much dissolved. Now, again, I think this is a sin on the part of them not allowing us into lab. Some of you have been in the lab months and months ago. If you remember, 1.9 milligrams, that's like 1 grain of salt. How the heck are you going to measure 26 micrograms? I mean, this is like nothing dissolving in a full liter. Or how much? I'm sorry, half a liter. No, it's a full liter. It's like not even a grain. You have to cut the grain into a small, itty bitty piece. It's okay. The mice in the lab right now can do that. All right. Is there any questions on this page? Page 32. We're good. So we have to make a choice. I have to make a choice. We're going to erase the board. The question is, oh, we should be chopping. We're going to skip a page. We're going to do that page tomorrow. We're going to skip the next page. We're going to do that page tomorrow. We're going to skip, I'm on page 35, where it talks about solubility and pH. You guys should be feeling really comfortable with pH. That is a comment that students will make. And I know several people have had conversations with me going, oh my gosh, I feel like I don't know anything. You actually have learned quite a bit. pH, hopefully by the end of this week, if not already, you've got it. You don't even have to think. You just go, okay, you do a negative log. It's below 7, it's an acid, it's above 7. I mean, you become comfortable with calculating pHs. So this is the common ion thing. So nickel 2 hydroxide is this. You have hydroxide. pH is definitely going to affect anything like that. So if we decrease the pH, that means it's more acidic. You all know that. That means you're increasing the hydronium. If you're increasing the hydronium, then you must be decreasing the hydroxide. So you don't have to write this out. We're going to do it actually when we do the math on question 1. If you decrease the hydroxide, what does Le Chatelier say will happen this time? You all know this. It's going to shift forward and it's going to become more soluble. So, which ones become more soluble to low pH? Any of them in which the anion is a base. Because as you lower the pH, the base is going to keep going into the solution to try to keep the pH balanced. So you're going to keep dissolving it. So the nickel hydroxide, yes, because of this reason. You know, I didn't give you a lot of space there, but you can doodle it wherever you find space. Calcium fluoride. And this was somebody earlier, we were talking about this. You have to be careful with the halogens. Chloride, bromide, and iodide are strong. or have no effect on pH. Fluoride is a weak base. So B, yes, it becomes more soluble. And that is because fluoride is the conjugate base of a weak acid. If you see a weak base, which would be fluoride, C, the answer is no, because you have a conjugate, and also D. So C and D, nope, because they're the conjugates. Well, actually, D's a crazy question. D's a silly question because nitrates are never soluble anyway. But the conjugates of the strong acids will not be affected. So chloride, bromide, iodide, nitrate, hydrogen sulfate, which we're not going to run into. All right, let's do the math. Is there a question with this? So A and B become more soluble for those two reasons. C and D, no effect. All right, the question wants us to write it out with magnesium hydroxide. So go ahead and write your equation. I'm going to use my hand to erase. Write your equation and write your KSP. And as I said in the email, the worksheet 3, you guys did so much better at showing your work. And as you're working on the titration lab, you will now understand why you have to label things so carefully, because there's so many pieces. And then it usually starts paying off at this point. Just always write the equation, solid to the ions, write your formula. Remember, the coefficient 2 becomes the exponent. And it just wants us to find the solubility. So again, I'm not going to walk through all the steps. You would look up the KSP in the chart. So this is from the chart. I gave it to you in the problem. So chart and notes, in case you didn't get that. And this is X, this is 2X. So this is one of those 4X cubed problems. You guys know how to do that. And you'll get my answer, and I don't know what my answer is. I've never given the answers before, you guys, because everybody used to come to lecture. I'm realizing the math department is like making mandatory lecture. I think I might do that in the fall, because it does make a difference. All right. Do you guys have magnesium hydroxide, right? I'm not doing the wrong problem. I assume so. All right, you find X. I got 0.035. That's going to be moles per liter. And then you would show your math. And I think I asked for grams. You'll end up with 2.0 grams per liter. All right. I have a question. What if I asked you, what is the pH of this solution? How would you find the pH of this solution? Just for the fun of it. It's like not there. We're asking like anybody?
Well, we know what the hydroxide is.
Do. So the mistake people make, 0.035 is not the hydroxide. What is the hydroxide, Harrison?
2 times 1.8 to the -4. E to the -4.
Wait, what?
I'm sorry, 2 times x. 2x, so.
Okay. I was like, am I doing a totally different problem? So if this is X, the hydroxide's double X. And then what do we do? You all know.
Log.
Negative log of that 2X, the 0.07. That's our POH. And then you guys all know the pH plus the POH is 14. And I got that 12.86. Right? You guys all can do that. You're like, yep, no problem. 2 weeks ago, it was a lot of students are struggling. Oh my gosh, what do I need? Looking for formulas. So hopefully you can do that. That was like an extra question thrown in there. All right, I'm going to erase my pH piece so we can do the next question, which is B. And this goes with what we just did. So now it wants to know, what if we're at a pH of 11? Well, if we're at a pH of 11, how does that affect this? How can I do any math? If you know the pH, pretty sure without a calculator, every single one of you can tell me what the pOH is. 3, right? Because those two always have to equal 14. Well, if I know my pOH, that means my hydroxide is 10 to the negative 3. So 10 to the negative pOH equals my OH. My magnesium is X. You set it equal to KSP and you solve for X. You shouldn't cross your arrows like I just did. It's a bad example. And you solve for X and kind of just follow along and hope your teacher did her work right. You get a crazy number. You now get that X equals 180. You may not think that's a crazy number. I do, because we're working with KSPs. We should be getting really small numbers. But on part A, our pH was 12.86. We just lowered the pH by almost 2 full numbers. That's a big difference. pH, every number is a huge difference. So when you solve, this is moles per liter. When you go to your grams, you get 10,500 grams per liter. Do you guys know how much 10.5? This is 10.5 kilograms. Do you know how much 10.5 kilograms is? Well, you could say, okay, that's like 23 pounds. That would be about right. That's a lot. That's like this huge bottle that you're just dumping and dumping and dumping and dumping and just keeps dissolving because we've buffered the pH. Yeah, I don't even know how you would do that. You'd have probably a whole liter solid. Anyway, it's a common ion. We lowered the pH, which means we lowered the OH. So it's shifted forward and it's more soluble. That's a tough question, but if you go back and look at it, it's pretty crazy. All right, go ahead and try number 2. Start number 2. And pause, hum, wait for a question. I'm going to erase. All right. What am I writing an equation for? Nickel nitrate or nickel hydroxide? Well, not the nitrate, because nitrate is Nic. Whenever you see nitrates, you are not writing equations with nitrates. You are not writing equations with sodiums or potassiums. It is the nickel hydroxide. And it also says to see the precipitate of the nickel hydroxide. In fact, if you're watching along at home, or when you watch along at home, let's all look at the chart. Let's find nickel on the chart. And let's find nickel hydroxide on the chart. Why do I have that number there? I have 2.8 e to negative 16. And if you look at the chart, are there any nitrates anywhere on the chart? I don't see Nic anywhere because Nic never precipitates. And if you go down below nickel, it goes to silver and then it skips to strontium. It skipped sodium completely. And if you go back to potassium, potassium starts with a P, not with a K. This chart's so confusing because you guys probably finally got that potassium and K, and you look for K. But anyway, potassium's not on here because they never precipitate. So write your equation. Write your KSP expression. The 2 goes outside. I know, so we're going to back up. Well, let's finish this problem, and then somebody remind me, I wanted to point out something about the previous question. And it wants to know, oh, it tells you have nickel nitrate. So that 0.010 molar of the nickel nitrate, we ignore nitrate. Nick is here. He's just here to be huggable. You know, it's a real bummer because usually on the test, I have a whole bunch of Nicks, and a number of people will hold Nick for the test. And then some lucky person gets me to sit next to them because apparently I ooze off answers. I don't sit next to any of the students. Anyway, this is your nickel. This is your X. This is what I wanted to point out. This drives all of you crazy. This is a question every single one of you will ask, even though I'll answer it today and tomorrow. If you know one of them, the other one is not stoichiometrically related. So it is just X. If you did not know either one of them, so on 1A at the top of the page, we did not know either one of them, so we had X and we had 2X. But as soon as you know one, the other one just becomes X. So we would just plug in 0.01. We do still square it, but we don't double it because there's no need to. It's not stoichiometrically related. And you would solve for X. X is your hydroxide, and you all know what to do from there once you get it. And I think, did I give you an answer? I have pH of 7.22. So it is slightly basic. Here's a question. This is a really good bonus question. Why is the pH barely above 7? I mean, it's just barely basic. But when we did the magnesium hydroxide problem, 1A, we got a pH of like 12.86. That one definitely made sense. It was like a really high pH. We would expect that. If you can get this answer, then you understand KSPs. It's a really tough question. Look at the value of the KSPs.
I was gonna say, is it because the KSP is such a low exponent or such a small?
Yes, Sam, you got it. This KSP, 10 to negative 16, like I cannot even fathom how small that number is. That's right, 0.00000. I have to count. There we go. That's what this number is. That's crazy. Who could figure that out? Like, how did they even figure this out? Doesn't make any sense to me. Whereas for the magnesium hydroxide, that number, I mean, it's still really small. If that was your paycheck, you really would probably not even be able to afford Mount Hood. But yeah, this KSP means This solid is barely soluble. I mean, like really, like just a granule would be in there. So it's really not contributing very much OH. So the pH just barely nudges above 7. All right, cool. Thank you, Sam. That is actually the big point of this whole lecture. All right, we got a page done. We have 3 pages done. We're gonna get through half of the next page, because this way you can at least do half of your study set, probably more than half. And then we'll go back tomorrow and fill in the other pages. All right. So I'm doing page 36, which has the big Q on it. You guys remember Q? Q is your friend. Usually at this point in the term, because everybody's in front of me, they're like, oh, good, we're doing a Q problem. I like Q problems. So you read the question, blah, 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 blah. It's all about silver chloride. First thing you do, and they all say in unison, you write the equation. So it's silver chloride, that's all I mentioned. Solid to ions. Those of you listening at home, if that's all anybody gets from this lesson today, is that you start with the solid and you go to ions, and that you only include the ions in the KSP formula. That's awesome. You're like, you can do that. All right, then you learn some. So the question is asking, will a precipitate form? If it asks this, it doesn't ask how much. It's not asking for any number. It doesn't say how much precipitate. Solve it as a Q problem. This is Q. And you go, oh, it's just a Q problem. So Q equals the silver times the chloride. And we can find the Q because I gave you a mass and I gave you a volume, right? 2 milligrams and 500. So go ahead and find your moles per liter. Well, I find mine. Until I was really into the fairy dust question. We needed a bit of magic. That's where rainbow squids come from. All right. Silver chloride. Oh, do you guys remember a little trick? Milli over milli, we can cross them out. So all I have to do is change my grams to moles. And I have this is like 143.5-ish. And I'll punch it in and I get a number, 2.8 e to negative 5. So that is my silver and that is my chloride. This is back to like what we did in the first page, but instead of solving for KSP, we're solving for Q. So Q is going to equal the 2.8 e to negative 5 squared. And you get 7.8 e to negative 10. All right, here we go. You know what we should do? That's what we can do for the bonus. I should say, and then I'll know if anybody watches my videos, but you can email me. What do you do at this point when you have a Q and you have a K?
You see if the Q is greater or less than the K.
Yeah. So you put them in alphabetical order. So this is how I know who's watching my videos, because on the test, about half of you did not know your alphabet. So we're going to sing it here. A, B, C, D, E, F, G, H, I, J, K. And then it goes like L, M, N, O, P, Q comes after. So alphabetical order means the K comes first. This is a trick a student showed me 20 years ago, and it is better than anything in any book or I've seen online, is you put them in alphabetical order. And then this was 7.8 e to negative 10. And this was 1.8 e to negative 10. Now, that's given in the chart. It was also given in the problem, but I want to mention it's in the chart because I don't always give it in every problem. The exponents are the same, makes this easy. 1.8 is smaller than 7.8. Or the alligator eats the bigger number because he's really greedy and he's really hungry, so he's going to eat the larger one. If you ever get to teach math to little children, it's really fun. You should like return to being a child and let the alligator eat the bigger one. All right, if you don't put in alphabetical order, this doesn't work. The alligator's nose points you in the right direction always. This goes reverse. What does that mean? What did my question say? Oh, yeah, go ahead, Harrison. Were you going to say something?
Yeah, it means that precipitates form because we have more products.
Well, it means it went reverse.
Reactants, not products.
The reverse is the solid. So it goes precipitate, yes. There is another way to solve this problem. You are more than welcome to do it that way. You will have to explain your answer. It requires you to think more. And what I have found in my many, many years of teaching and thinking, the less I have to think and be up here in the intellectual part, the better the answer comes out. So if you just do the alphabet, which you should all sing in the shower or hum the alphabet song, because humming and singing are really good. And like this whole vibrational thing, and it will make that child in you come out again if you sing the alphabet song. Don't do it backwards, even though that's really cool. All right, we're going to skip number 2. We're going to move on to number 3. If you already did number 2, that's fine. We're going to do it tomorrow. But I want to do number 3. So those of you who do like to get ahead and start working on your homework, you can. In what time? Oh, good. Perfect. All right, so on number 3, my question is, what is the precipitate on number 3? So we're on page 36, number 3. Is our precipitate. You're not writing the whole equation out. What ions are you going to cross out of the question right from just reading it, even as words? Well, so don't answer me. Here we go. So if you're playing along at home, and you're like, I can never go to her lectures. I like listening to them at 2 in the morning. I think that's Jessica and Megan. You can email me. You can tell me the KQ trick and tell me what ions you're going to cross out in question number 3 on page 36. And I'll give you a bonus point because at least I know you're listening to my lecture. And if you don't like my lecture and you like listening to some other guy, that's awesome. You can keep listening to the other guy. And Nick's got like a cool like thing around his neck. I never noticed that. I wonder where that came from, Nick. Okay, this is Nick the third. The other Nicks are still there. And Nick's girlfriend's still there in the office. They're hanging out. So I actually have 4 camels. All right, you're going to cross out, and they all say in unison, Nick. So there's no nitrate. We do care about the nickel. And again, the Roman numeral 2 is the charge. And you're going to cross out the sodium. So you're left with carbonate. Yeah, and again, those of you who had me for 221, hopefully you still have your hot pink periodic table that had the polyatomics. because it's a lifesaver here. If you were somebody who's like, hey, I want one of those tables, Dr. Sherpa. Oh, you know what? I actually have a scanner at home. I can scan it to you. Because having it, and just having one piece of paper instead of all these huge lists that many of you like, yeah. All right, write your equation. You have to, on this one, you are not writing the full double displacement. All you care about is the precipitate. This is all we care about. It must be the nickel carbonate. It's a huge shortcut that you never, some of you maybe never learned. All right, our KSP expression is just the nickel and the carbonate. You know what, I'm gonna write it down here because I know where I'm going. Oh, I want to make one other quick comment. I know I made it back before. These are technically brackets because it is molarity. I have no problem with parentheses. It's like a personal thing. Some people, they have to have brackets. So the precipitate is nickel carbonate. We do not have an X in this problem. We're doing, this is Q. Because again, it doesn't say how much forms. If you go down, if you look at the very last question, number 5, where it says what mass precipitates, that is not a Q. But 1, 2, and 3 are Q problems. All right, so nickel. Some of you are gonna go, what did she just do? So it says it's 1.5, and it's that funny little mu sign. Some of your printers do not like that. If it shows it as a box and then a capital M, just go back in and look, because my thing that I posted will show it correctly. What this means is you have 1.5 e to negative 6 moles per liter. That's what the little micro means, but you're not done yet. The volume changed. We started with 100 mils, we're ending with 200 mils. So we have to multiply by the initial volume over the final volume. This is just my nickel. So a question that often comes up at this point, somebody will say, don't you have to change it to liters? Because this is moles per liter. If you're asking that question, then my answer would be yes. But I didn't have to because the volumes cancel. So as long as they're the same units, it doesn't matter. All right, the carbonate then was, like, I'm writing underneath 0.60 millimolar. So milli is 10 to negative 3. And then I have to move it one more. So this would be 6.0 e to negative 4 moles per liter. And then again, we have to multiply by 100 milliliters over the 200 milliliters. This is my total volume down here. And this was just me changing. You can go through the step with the metric, or you can recognize, some people can do it. I'm just watching the time. And if you're not sure, please come and ask me and say, hey, can we go over that problem, how you got from millimolar to moles per liter. All right, we punch it in. This is going to give us Q, because we knew how much we mixed of each piece. Oh, which is, again, the nickel times the carbonate. So that's what I just erased there. Anyway, Q equals, right up here, so we're complete. You don't lose a point on every problem because you're not able to show this step. Maybe you guys have a huge advantage, because this is when some students will just skip a whole day. And so you guys can miss a day, but then you got to go and watch the video or some video, and they get sloppy and they don't show these pieces. You've got to show your work. You all wanted to show your work. You got to show it. All right. This is our answer in the past 10 years, 20 years of doing this problem. Alphabetical order, K comes before Q. That's Q. This is when we mix two things. So you mix two solutions. That's a Q problem. Sorry, Hill. All right, what's my K? I didn't give it to you. Oh my God, you freak out? You start like cursing and my ears don't ring. I sleep. I go far, far away in my sleep. Oh, you go, oh no, she was so kind. What a kind professor. She gave us these charts, so I didn't have to go online and get different answers than everybody. 6.6 times 10 is I'm hoping it doesn't matter because both numbers I have in my chart. All right, 6.6 e to negative 9. This number, they're negative exponents. The Q is the smaller number this time. It's going to have more zeros. Alligator's nose points the way. It goes forward. Forward means aqueous, no precipitate. So you're going solid is on the reactant side to aqueous on the product side. So if it moves forward, no precipitate because it went to the aqueous side. Aqueous means they're swimming with the rainbow squid and Nick. We're swimming. All right. Again, always cross Nick out. He has no effect. Cross sodium, potassium out. We'll do the rest of this page tomorrow because we've already done 3.5 pages out of 6. Any questions before I stop? All right.
I have a question.
Go ahead, Jim.
So when you use the Q question,
Yeah.
when you use this,
When to use Q?
yeah.
If you look on this page, 1, 2, and 3, I know right off their Q questions, they don't ask how much. They ask just yes, no. Will a precipitate form? Does a precipitate form? So do you see that when it's a yes, no question like that?
Oh.
So
yeah,
that's
I
why
got that.
1 and 3, will a precipitate form? Does that make sense?
Yeah, okay.
There is another way you can solve 1, 2, and 3. It requires more logic, which some of you could do that. It just requires you to think more, and it actually takes more steps.
Thank you.
You're welcome. I didn't know you were here. I can't only see 3 people at a time. Anybody else have a question? That was an awesome question, Jim. All right. I am going to stop recording.